All right. Hey again, Honors Chemistry. So now I'm going to do half of question number 6. We have talked about ions in solution, but now we're going to have to apply that here. It says identify how many ions each ionic substance would produce, sorry, typo, when dissolved in water, and draw a particle diagram of each of these ionic substances in solution. Then calculate the molarity of each ion present. So let's do the first one. I have AlCl3. This is an ionic compound. There are how many different ions? Well, there's Al and 3 Cl's. So it's going to be Al, and that has a charge of 3 plus, and there are 3 Cl minuses. So there's going to be 4 ions in total. Now this is a throwback to Unit 5 and 6 a bit, right? All of the ions are the different ions that are present. So like you'll see later, this is Na2CrO4. So that has 2 Na pluses and 1 CrO4 minus 2. Sorry, that should be a little 4. Okay? Like calcium hydroxide has Ca2 plus and it says OH2, so 2 OH minuses. This has 3 ions. This has 3 ions. And then Na3PO4 has 3 Na plus 1s and 1 PO4, 3 minus. That's 4 ions. Okay, so I already gave you the answers for these. And now I'm going to show you how we're going to do a bit of math where it wants the molarity of each ion present. Well, I gave you 0.25 molar AlCl3. For every one, I'm going to say 1 mole of AlCl3, there are 1 moles of Al3 plus, and there are 3 times as many moles of Cl minus 1. And we talked about this in class. So whatever the concentration is, I'm multiplying times this ratio. So for every 1 AlCl3, there's 1 Al, the concentration, which I'm going to show you that's in brackets, the concentration of Al3 plus is going to be 0.25 molar. But for Cl minus, there's 3 times the amount of Cl minus. So I'm going to do 3 times 0.25 molar, and that's going to give me 0.75 molar is the concentration of Cl minus. Okay, I'm going to do another one. I have 0.375 molar of Na2CrO4. Now, there are 2 NAs that are going to dissociate. So this concentration is of this whole thing, but for every 1 mole of Na2CrO4, there are 2 moles of Na+. So what I'm doing is, I'm going to take this concentration and multiply it times 2. So 0.375 molar times 2 is going to be equal to 0.375 times 2. I get 0.75 molar of Na plus 1. Okay? And then for every 1 molar of Na2CrO4, there's going to be 1 mole of CrO4 2 minus. Since there's only 1, I'm only going to multiply the concentration by 1. So the concentration, and I'm going to show you, we could do that in brackets, the concentration of CrO4 2 minus is equal to 0.375 molar. All right, so it looks a little bit messy here, but I did the first 2 for us here. And I'm going to set us up on the next one. And I'll mention this in class, but brackets now mean molarity. So if I ever see brackets now, that means molarity in moles per liter. Okay, I'll do the letter C, and then I'm going to leave you to do D on your own. But for letter C, I have, that should say molar. I have 0.002 molar calcium hydroxide. There's only 1 calcium 2 plus, right? So I'm only going to multiply that times 0.002 molar, and that gives me 0.002 molar is the calcium 2 plus ion. There are 2 hydroxide ions. Right, there are 2 hydroxide ions, so I'm going to multiply that by 0.0020 molar, and I get 0.004 molar hydroxide ion. So I just set you up to do A, B, C, and D. I will talk more about this in class about how we talk about the ions, and I already did probably talk about how the ions, I multiply the number of ions by the concentration, and that is going to be the concentration of the ion. Very straightforward. All right, so little bit longer video, but use this as an example to try and do letter D. There are 3 sodium ions. What am I doing with that 3 and 0.103? And there is 1 PO4 minus ion. What am I doing with that 1 and the concentration of 0.103 to get the concentration of PO4 ion? All right, so I'm going to leave this up to you. What is the concentration of Na plus? And what is the concentration of PO4 3 minus?